Hello friends, here in this video we are going to see a problem on pentagonal pyramid. Here is the question. A pentagonal pyramid, side of base 35 mm and axis 70 mm long, is lying on one of its corners on HP. So first I'll explain this condition. Just by reading the problem it is understood that the type of solid is pentagonal pyramid. I'll draw the diagram for that. Now this is a pentagonal pyramid in which the base is in the shape of a pentagon. It has 5 base edges and 5 corners. Here is the apex O. These are the slant edges, and here are the triangular faces. So this pentagonal pyramid has 4 base corners which are connected to the common apex by the slant edges forming the triangular faces. Now in the question it is mentioned that pentagonal pyramid, side of base 35 mm and axis 70 mm long, is lying on one of its corners on HP. So when the condition is of corner, we will draw it in this manner, which I will explain it here. Base edge is 35 mm. Marking 35 mm. Measuring 72 degree, because the edges of the pentagon are inclined at 72 degree. So measuring it from both the points. Measuring the edge here. Marking it on one side and on the other side. Drawing an arc from here, light arc, cutting it from the other side. Here we get a corner, so I'll connect it first with the help of light line forming the pentagon. Next, drawing the midpoint of one side, so half of 35, 17.5, joining it to the opposite corner. Then taking the midpoint of any other side, joining it to its opposite corner, so here I get a point which is giving me the apex. Forming the slant edges. So here if we see this pentagonal pyramid, it is resting on its corner. I'll give it as corner A. So as per the given condition, we have to draw the pentagon in this way, that is, it should rest on this corner. So with this we can start with the solution part. XY line VPHP. Next, drawing the pentagon in this way. Drawing a light vertical line. Over that I'll mark the distance. Here I have taken the true shape, that is the true length, 35 mm. So this is the same pentagon which I have to copy here, resting on its corner. Drawing 72-degree line from both the points because the edges are inclined at 72 degree. Joining it with the help of a light line. Similarly 72 degree onto the other side. Joining it with the help of a light line. Now here I'll draw this pentagon, keeping the same distance as 35 mm, marking it on one side, next onto the other side, drawing a light arc, cutting it from the other side. Next, for the apex, again I'll mark the midpoint of any one of the sides and onto the any other given side, and joining them to their respective opposite corners. Like this midpoint would be joined to this opposite corner. You have this midpoint to its opposite corner. Wherever these two lines intersect, that becomes an apex for us, point O. Then joining all the corners at this apex to get the slant edges and the triangular faces. I'll give the notations to this pentagonal pyramid. Now I'll draw the front view of this pentagonal pyramid, where it is given that axis is 70 mm long. So marking 70 mm over the axis, that gives me the point O dash. Giving the notations, here we have 1 dash comma 2 dash, this is 3 dash, 5 dash, here we have 4 dash, then making it dark. Joining the slant edges as well to get the triangular faces. So this is the pentagonal pyramid when we are looking from top. Now the front view for the same. Next, joining the axis. Now this is the initial condition of the pentagonal pyramid. After that, I'll read what is given in the problem. A pentagonal pyramid, side of base 35 mm and axis 70 mm, is lying on one of its corners on HP, such that the two base edges passing through the corner on which it rests. So the base edges which is passing through this corner, which is 4, the base edges are 3, 4 and 4, 5, makes an equal inclination with HP. So these two edges will be making equal inclination with HP, that will be visible in VP. Next, one of its triangular face is parallel to HP and perpendicular to VP. So the next second condition would be taking the triangular face parallel to HP and perpendicular to VP, and the base edge containing that triangular surface is parallel to both HP and VP. So here the condition is, first of all, the two base edges passing through the corner on which it rests, that is 4, makes an equal inclination with HP. One of its triangular face or surface is parallel to HP. Now the second condition is the triangular face, one of the triangular face is parallel to HP. So here I'll make the triangular face O dash, 1 dash, 2 dash parallel to HP. And why this face is made parallel? Because the pyramid will be tilting about its corner. So when it is tilting about its corner, there is an edge, or we can say the triangular face O12. This triangular face will become parallel to HP, and then it will be perpendicular to VP. So in the second condition, I'll have to make this parallel, and for that, first of all, I'll draw a light vertical line in order to make it parallel. Drawing a light perpendicular line. Next, first I'll make this distance, that is 4 dash to 1 dash, taking this distance and marking it over this vertical line with a light arc. Next, after this, taking the same distance and here, after I have marked this, that is the distance from 4 dash to 1 dash, the edge which is O dash, 1 dash, 2 dash should pass through it, that is making it parallel, and I'll draw first of all a light line through this point, light parallel line parallel to XY, a light parallel line. So now here I'll be making this O dash, 1 dash, 2 dash parallel, and for that here I'll explain the procedure how to do that. First of all, from point 4 dash, drawing a parallel line through 4 dash, a light parallel line as the reference. Next, keeping this parallel line as the reference and dropping a perpendicular on the slant edge which is on the opposite side. So this perpendicular I have dropped onto the slant edge O dash, 1 dash, 2 dash. I'll call this perpendicular as 4, since it is here at 4 dash, this I'll call it as M dash. Now I'll make this perpendicular in such a way that I'm going to take the distance 4 dash to M dash, and then marking it over this vertical line which I have drawn just now, marking it over here. Now this vertical line means here it is 4 dash, point 4 dash and point M dash. This is the vertical line. So if I make one line vertical, that is 4 dash M dash, automatically O dash, 1 dash, 2 dash will become parallel to XY line. So here through M dash I am drawing a light line then I'll measure the distance from M dash to 1 dash, 2 dash, marking it here. So that gives me 1 dash comma 2 dash, and from M dash up to O dash here I am getting O dash. Now joining them in proper sequence, first with the help of light line, then after getting this, here is the base edge 4 dash, 1 dash, 2 dash. I'll mark the distance from 1 dash, 2 dash up to point 3 dash, 5 dash. So here it is giving me 3 dash comma 5 dash, then measuring the distance up to the axis from 1 dash, measuring the distance up to the axis, then drawing the axis first by joining it to the apex, Next, I'll be connecting all these slant edges one by one, starting with O dash, 1 dash, 2 dash. Then this base edge, joining 3 dash, 5 dash to O dash. So now in this way the pyramid will be tilted, and here as we see the triangular face is parallel to HP and perpendicular to VP, because parallel to one plane means perpendicular to the other plane. So here it was mentioned that it is parallel, the triangular surface is parallel to HP. Now I'll draw the front view, the top view for this, because this is the front view. So in the top view the observer is here, and as an observer whatever points are closer to me that will be projected first. So starting with the apex, and here also the apex will be projected. So this gives me point O. Next 1 dash, 2 dash will be projected light. Point 1 from the top view will be projected here. Point 1. Next 1 and 2 are on the same line, so here I'll project 2 as well. Three and 5 are onto the same line. Point 3 will be projected. Next point 4. Here there is point 4 from the top view. Then point 5, 3 dash, 5 dash are onto the same line. This gives me point 5. Now joining all the points in proper sequence, first with the help of light line, then making it dark. So point 025 will give me this slant edge. Next point 023. Then 1 to 2 is already connected. 1 to 5 will be visible from the top. Similarly 1 to 3 will be visible. Then when an observer is looking from the top, the triangular face O dash, 1 dash, 2 dash is closer to observer, so it will be seen. So connecting O to 1 with the help of a solid line. Similarly connecting O to 2 with the help of a solid line. Now only point 4 is that which is going behind the observer, so the edges connecting point 4 will be hidden. First I'll draw the visible portion of this pyramid. Now I'll make the outer edges dark. So these three edges 1 to 2, 2 to 3 and 1 to 5 are visible from the top, but edge 4 to 5 will be hidden going away from the observer, and edge 3 to 5 will also be hidden going away from the observer. At the same time, O to 4, this slant edge will be hidden because it is behind the observer. So now if we look from top, the three triangular faces O15, O12 and O23 are visible. Remaining two triangular faces O45 and O43 are going behind the observer, so they are hidden. Next, I will project the apex also. In the top view, here this is the true length of the axis. In the top view, it will become the apparent length and it will coincide with the hidden line. So this will be the apex, or we can say the axis. Next, after this we are going to complete the third stage of the problem. So here, after I have completed the second stage, it was given that the triangular face is parallel to HP, and when this triangular face is parallel to HP, its edge, that is 1, 2, that edge is also parallel to HP. If it is parallel to HP, then it is perpendicular to VP in this condition. And the next condition is one of its triangular surface is parallel to HP perpendicular to VP, and the base edge containing that triangular face. So base edge which is containing the triangular face, which triangular face? Which is parallel, that is O dash 1 dash 2 dash. In the top view it is O12. So the base edge contained by this triangular face is parallel to HP and perpendicular to VP, and the base edge containing the triangular surface is parallel to both HP and VP. So even this base edge is parallel and perpendicular to both HP and VP. So in this condition the base edge is parallel to HP. Now I'll use the second condition and make this base edge parallel to VP, because it is given that the base edge containing this triangular face is parallel to both HP and VP. So if I have to make it parallel to VP, I have to draw a line perpendicular to XY. So it will be seen in the top view. Drawing a light line, and that edge is 1 to 2. So taking this distance, that is 1 to 2, and marking it over this light line. So here we have, this is edge 1 to 2, this is point 1, and here we have point 2. Next, I need to plot all the points, that is copy this complete pyramid here in the vertical position, and it is mentioned that draw the projections of the solid when the apex of the pyramid is nearer to observer. So we have to tilt this pyramid in such a way that this apex O is nearer to observer. It means edge is at the top. If the question would have been that the apex is nearer to VP, then this edge 1 to 2 would have been at the bottom. Now since observer in the top view is fixed, observer is here, so we have to make the apex come in contact at this location. Now I'll take half of 1 to 2, that is the midpoint of this line, then drawing a perpendicular line through it. Next, I'll be marking the distance from 1 to 2, this edge up to the apex, and copying this distance over here. So this is giving me apex O. Next, I require the other points, like for example point 4 is there on this line itself, so I'll measure the distance from this edge up to point 4. So here we have point 4. Then I require these points 3 and 5. For that I'll measure the distance between edge 1 to 2 and this vertical edge which contains 3 and 5. Marking it on this line, then drawing light parallel line which is parallel to 1 to 2. So drawing a light parallel line and then measuring the distance from the center up to point 3 or point 5, both will give me the same distance. So here we have point 3 and this will be point 5. Next, joining them with the light line first to complete the pyramid. Now I'll make it dark. Edge O21 and O22 are dark. Next, outer edges O23, O25 are dark. Then point 4 is hidden because it is going behind the observer here, so that was to be drawn with the help of dotted line. Then even O24 was a hidden line. Now this is the pyramid in which the edge 1 to 2 is parallel to VP. Previously the same edge was parallel to HP. Now it is parallel to VP. So as an observer here, observer is at the bottom. So those points which are closer to the observer will be projected first. If we look from here, apex is closer, so apex will be plotted first. Here O from the top view and O dash from the front view gives the apex, which is point O double dash. Next, after that, the points 3 and 5, they will be projected. So here point 3 and 5 are onto the same level in the front view. So 3 dash 5 dash will be projected here, and that gives me 3 double dash 5 double dash. Then point 4 is over this vertical line where it intersects 4 dash, which is on xy line. Here we have point 4 double dash. Then points 1 and 2 are left. So now here when we are looking as an observer, the pyramid is kept in such a way that points 4 double dash to 5 double dash will be visible. 4 double dash to 3 double dash, that will also be visible because they are forming the outline. Then I need to project points 1 and 2 as well. Then 1 dash 2 dash, this point is lying on the same line as that of the apex O double dash. So here I'll get 1 double dash, and at this location 2 double dash. It means when I connect this with the help of a line, so the triangular face O12 is looking like a line in the front view. So connecting all the points here, edge 5 double dash to 1 double dash visible, 2 double dash to 3 double dash visible. Next 2 point O double dash 5 double dash are connected. O double dash 3 double dash are also connected because they are closer to the observer. Edges are visible. Next, here I'll make it dark. So this is the complete pyramid wherein all the slant edges are visible and the pyramid is kept in such a way that apex is closer to the observer whereas base is going away from the observer, and in the front view it would be looking something like this. And here if I see the two base edges, these base edges are inclined at an equal angle to HP, because in the problem it was mentioned that, I'll read the question again and explain. A pentagonal pyramid side of base 35 mm and axis 70 mm is lying on one of its corners on HP such that the two base edges passing through the corner on which it rests. So it is this corner on which the pentagonal pyramid is resting, and through this there are two edges 3 to 4 and 4 to 5. So the base edges passing through the corner on which it rests makes an equal inclination with HP. So this condition we have finalized at the last stage, that this is the corner on which the pyramid was resting and the edges passing through it are making an equal angle with HP seen in VP. And initially whatever the conditions was there, we have completed and reached up till this stage. So here I'll give the dimensioning to it. The base edge is 35 mm, axis height 70 mm, and here in the first condition it was mentioned that the triangular face is parallel to HP. This edge 1 to 2 is parallel to HP, perpendicular to VP. In the second condition, the edge is parallel to VP, and with this we complete the problem.